Now we will going to assume a few things about the error term in the population model. So the first assumption I have told you that the expectation of the error is 0. And the second is the variance of error is same for all values of the independent variable. The values of error are independent and error is normally distributed random variable. So these are the assumptions we are going to make for the term epsilon in the population model of simple linear regression. So now we have two tests. We have two tests. So to test for a significant regression relationship, we must conduct a hypothesis test to determine whether the value of beta 1 is 0. Of course, if beta 1 is 0, then there is no relationship. That's why we are going to discuss the relationship between the independent variable x and the dependent variable y. Yes, yes, they are different. So, one is t-test and the other is f-test. So, both the t-test and f-test require, yeah, I'll tell you in a meanwhile. Just hold, just wait for a few minutes. So both the t-test and f-test require an estimate of sigma square, that is the variance of error. So an estimate of error that is given by MSE. MSE means sum of squares of errors by degrees of freedom. So SSE, just now I have told you, SSE means sum of deviations square. Deviation means yi minus yi crown. That's what just now we calculate. So we want to take the estimate of sigma means square root over MSC, that is square root over SSC by n minus 2. Why 2? Because we have two unknowns B0 and B1. Then what is your hypothesis in t-test? H0 means no relationship. HA means there is a relationship. So test statistic T is given by B1 by variance of standard deviation of B1. So standard deviation of B1 is given by S by square root over summing xi minus x bar whole square. Yeah, because we are doing this test because we want to check whether there is a relationship between x and y or not. B1 equal to 0 or beta 1 equal to 0 says that there is no relationship. Not equal to 0 says that there is a relationship. So as usual, rejection rule is p-value less than or equal to alpha is for p. Otherwise, we use a two-tailed test that if t is between minus t alpha by 2 and plus t alpha by 2, we say that it is in the acceptance region. Otherwise, it is in the rejection region. Please remember, we are using degrees of freedom n minus 2 because we have two unknowns b0 and b. So the procedure is like this in t-test. So null hypothesis is no relationship, beta 1 equal to 0, and alternative hypothesis beta 1 not equal to 0. There is a relationship. Next, specify the level of significance alpha, that is 0.05. And the test statistic T is given by B1 by S beta 1. So B1, you know, you have already calculated for the equation. SB1 means, just now I told you, it is S by square root over sigma x minus x bar whole square. So then you just use the rejection rule and finalize the problem. So in the current question, you have to reject H0 if p value is less than or equal to 0.05. If you want to use a critical value method, then mod t should be greater than table value. Table value is for alpha equal to 0.05 and 3 degrees of freedom because 5 observations are there for each x and y. So compute the test statistic T is 4.63. Because it is a two-tailed test, you can calculate the p-value is twice of t greater than or equal to table value. That's it. So you have calculated R square. R square means the coefficient of determination, and after that we calculated the correlation. Coefficient is its square root. That's it. Now, so far what we have done, I'll recall and I'll repeat because like so far what we have done, so we want to test the significance relationship between x and y. So that's what we have done using t-test. Now we want to construct a confidence interval for beta 1. Beta 1 is a parameter unknown. The statistic corresponding to beta 1 is b1. So we can use a 95% confidence interval for beta 1 to test the hypothesis just used in the t-test. I'm not going too fast. It's like I'm going in an average speed. I'm only skipping the calculations which one can do that. So the next one, I'm using a 95% confidence interval for beta 1 to test the hypothesis just used in the t-test. So the alternate method I'm giving. So H naught is rejected if the hypothesized value beta 1 is not included in the confidence interval for beta. So the alternate formulation I told you, for testing the hypothesis, either we have a test statistic method or a confidence interval method. So I'm repeating what I have done so far, maybe if you have an idea. Right? So what I have done so far is, there is a dependent variable y and an independent variable x and an independent variable x, and we want to find a relationship between x and y, right? We want to find a linear relationship between x and y, maybe assuming that there is a linear relationship between x and y. So we are finding a linear relationship between x and y. So the population model will write as y equal to beta naught plus beta 1 x plus epsilon. Why epsilon? Because there is an error always. But the regression equation means, under the assumption that the expectation of error is 0, the regression equation becomes expectation of y is beta naught plus beta 1 x. This is for the population. So obviously we don't know the parameters beta naught and beta. So for that reason, we have a sample data of x and y. For this sample data, we will calculate the estimated regression equation, not the regression equation. Why? Because in place of beta naught, we are writing the estimated value b naught, and in place of beta 1, I am writing the estimated value b1, because b naught and b1 are sample statistics. Then of course b naught and b1 estimates beta naught and beta 1. So on the whole, I want to construct a y equal to beta naught plus beta 1 x plus epsilon model for a population. It's not possible. So to calculate the unknown parameters beta naught and beta 1, we estimate them through sample statistics b naught and b1. That's it. It's an estimation. So finally, we have two formulas to calculate B1 and B0 for the sample. B1's formula is summation xi minus x bar into yi minus y bar by summing xi minus x bar whole square. This is the formula for B1, and the formula for B0 is y bar minus B1 x bar. So I have shown you the derivations. So for a given sample, you can calculate B0 and B1 using these two formulas. So for a given example, I have X and I have Y. I have 5 values for each X and Y. I calculated X bar, I calculated Y bar. Then I calculated B1 and I calculated B0 by using the formulas. So what is the estimated regression equation you got? Y crown is equal to 10 plus 5x. Why? Because, yeah, it's like the identification of x and y. X is always an independent variable and y should depend on x. So for a given question, one can easily identify x and y, because in the previous example, what the question says that if Read Auto periodically has a special week-long sale. As part of the advertising campaign, Reed runs one or more television commercials during the weekend preceding the sale. Means the question says that if you increase the, or if you campaign rigorously, maybe more number of cars will be sold. Yes or no? That's why number of TV ads is independent and number of cars sold always depend on number of TV ads only. Then so far we have calculated a relationship like this. This is the linear relationship between x, the independent variable, and y, the dependent variable. Please remember, here we have done it for sample. Yes or no? Because originally the model must be y equal to beta naught plus beta 1 x plus epsilon. This is for population. But we cannot do it for population, so we did it for a sample. So that is y crown equal to b naught plus b1 x. So this is the estimated regression equation. We did it here. Now this is giving a linear relationship between x and y in the form of an equation. But sometimes you can have a numerical relationship between x and y. So those numerical relationships are given by two quantities called coefficient of determination and the correlation coefficient. So the next two are telling the numerical relationship between x and y. The previous one says a linear relationship between x and y. So as usual, if you see here, yi is the observed value, y bar is the mean of y. So summing yi minus y bar whole square means sum of squares of deviations. So what are those deviations? Observed value minus mean. This is known as total sum of squares. Sum of squares of regression, how do you calculate? Sum of squares of deviations. What deviation I am taking? Estimated value minus mean. So sum of squares of deviations, here deviation is estimated value means mean. Sum of squares of errors means again sum of squares of deviations. But what is the deviation here? Observed value minus estimated value. Then the coefficient of determination is given by sum of squares due to regression by sum of squares total. So it is coming out to be 0.8772. Please remember, you can calculate sum of squares due to regression and sum of squares due to total. So the regression relationship is very strong because it is close to 1. Yes or no? Why? Because r square, anyhow I'm denoting it, it is a ratio of two positive terms. So it should be lying between 0 and 1. 0 means no relationship, 1 means perfect relationship. Apart from this, you have one more numerical measure called correlation coefficient. We know that correlation coefficient also gives a relationship between x and y. Yeah, so it is given as sine of b1 into square root over r square. So obviously this relationship lies between -1 and 1. So we have the relationship coming out to be 0.9366, which means that it is very close to 1. We have a strong positive relationship. If it is -1, then it is a perfectly a negative relationship. 0 means no relationship. So r square, the coefficient of determination, gives the strongness of the regression, and r gives the relation between x and y numerical. Please remember, coefficient of determination gives the regression relationship between x and y numerically. It is lying between 0 and 1. R gives the numerical relationship between x and y. It lies between -1 and 1. So we have some. So this shows that there is no relation between x and y. This is a negative relationship and this is a positive relationship. So if positive relationship means it will be like this. Negative relationship means it will be like this. No relationship between means it will be like this. Now the question is that we did for sample, but you have to apply for a population. Yes or no? Because we have done for a sample. Yes. We have done for a sample, but you have to apply for a population. Then what you will do? We have to apply a significance test. That's what we are doing here. So y crown equal to y equal to beta naught plus beta 1 x. This is the estimated regression equation. So if beta 1 becoming 0, then what happens? Then there is no relationship. So we have done for a sample and we are going to do it for a population. So generally we have to check whether there is a relationship in the population or not by using samples. So the first test is, yeah, the first test is, now the first test is, the first test is t-test, where the null hypothesis is there is no relationship between x and y in the population. Alternate alternative hypothesis, there is a relationship between X and Y in the population. So test statistic is given by B1. This is calculated for sample by SB1. This is the standard error of B1. How do you calculate standard error of B1? This is S by square root over sigma xi minus x bar whole square. Xi means the ith observation of x. X bar is the mean of x. How do you calculate S? S means nothing but sum of squares due to errors. Do you know how to calculate sum of squares due to error? Sum of squares due to error means summing all squares of deviations. What are the deviations? Observed value minus expected value. Degrees of freedom is n minus 2. Number of items in the sample minus 2 because two unknowns B0 and B1. So once you calculate sum of squares due to errors, then mean sum of squares due to error is SSE by n minus 2. And this is known as S square. Once you calculate S square, you can calculate S. So that is the S. So rejection rule always reject H0 if P value is less than or equal to alpha. If you want to use a critical value hypothesis, then the rejection region is either below minus T alpha by 2 or above T alpha by 2. In between, we have an acceptance region. So your null hypothesis is beta 1 equal to 0. There is no relationship. Alternative hypothesis, there is a relationship. Level of significance is 0.05. Test statistic, because test statistic should be depending on B1. So that's by B1 by SB1. So rejection rule is reject H0 if P value is less than or equal to 0.05. Or critical value hypothesis, mod T is greater than 3.18. How do you got 3.182? Alpha is 0.05. So alpha by 2 is 0.025 and degrees of freedom is 5 minus 2 is 3. So test statistic you calculated as P equal to B1 by SB1. B1 you already calculated. SB1 you can calculate using the formula and you got it as 4.63. So now for a given table, given calculated value 4.63, P value is nothing but twice of probability of your T is greater than 4.63. So then it came out to be less than 0.02. So we can reject H0. So far what we have done, we have used a test of significance to test where there is a relationship between X and Y in the population or not. But during the earlier classes, we came to know that testing of hypothesis can alternatively done with a interval estimation. Yes or no? Because interval estimation is also one of the other techniques to test the significance. Now what I am doing is that I am constructing a 95% confidence interval for beta 1. If beta 1 is there, if beta 1 equal to 0 is there in the confidence interval, then we say that accept H0. Otherwise we say that reject H0. Yes or no? Because null hypothesis is beta 1 equal to 0. If beta 1 equal to 0 is there in the interval, we accept H0 because confidence interval is nothing but what? Acceptance region. So the confidence interval, as usual, you know, B1 is your test statistics. B1 plus or minus T alpha by 2 SB1. Yes or no? B1 plus or minus T alpha by 2 SB1. So this is the confidence interval for beta 1. So The confidence interval is coming out to be how much? 1.56 to 8.44. But 0 is there in this or not? 0 is not there. So that's why what we say, 0 is not there in the confidence interval, which means we reject H. There is an alternative method to calculate or to test the significance using F test. Same F test, yeah, yes. Yeah, please ask me. Please ask me. Yeah, any question you please ask me now. Yeah, if you want, I'll provide the page numbers later stage because it's difficult to write page numbers on each slide from which topic I'm writing. Yeah, I'll do that in the next slides. I can understand that. Yeah, you can use any one of the tests, either T test or F test, whichever is required. T test can alternatively calculate using confidence interval. Both ways you can use any one of the ways. If you want to use, yeah, if you want to use F test, then the F test is nothing but the ratio of two variances. Yes or no? So F is given by mean square due to regression by mean square due to error. Same rejection rule is reject H naught if p value is less than or equal to alpha, or if your calculated test statistic comes above your table value. Yes, I'm going to solve it. Same same method for F test also. So null hypothesis there is no relationship. Alternative hypothesis that there is a relationship. Alpha is given as 0.05. So F is given by MSR means mean sum of squares due to regression by mean sum of squares due to error. Reject H naught if p value is less than or equal to 0.05, or F should be above the table value. How do you calculate table value? Alpha is given by 0.05. The numerator degrees of freedom is 1 and denominator degrees of freedom is 3 because number of sample observations minus 2. 2 because B0 and B1 are unknowns. So after calculating capital F, it came out to be 21.43. So either you can use a p-value approach or you can use a critical value approach to accept H naught or reject H naught. Okay. So I'll take a small break and I'll come back. So far we have constructed a linear relationship between X and Y. After that, we calculated B0 and B1 for sample. Then finally we used t-test and f-test to check whether there is an actual relationship between X and Y for the population. So in t-test we have two methods, one by using the test of significance or by using the confidence interval. Whereas in f-test we have a F statistic. Apart from these two, we have also calculated coefficient of determination as well as coefficient of correlation. Y crown equal to B naught plus B1x gives a curve relationship between x and y. Coefficient of determination gives the strongness of their regression. And coefficient of correlation gives a numerical measure of relationship between x and y. Coefficient of determination lies between 0 and 1, and coefficient of correlation lies between -1 and 1. If coefficient of correlation is 1, strong positive relationship. If coefficient of correlation is 0, no relationship. If coefficient of correlation is -1, strong negative relationship. So that's all for today. I'll bring with a new problem which is covering all these aspects so that you can clearly understand with an example. Thanks for today. Yeah, there is a relationship between coefficient of correlation and determination. You know coefficient of determination, you can calculate coefficient of correlation. So the formula says like this. Rxy equal to sine of B1 into coefficient of determination. Okay. Thank you. Thank you for today.